Imagine uncovering a tomb in ancient Egypt, sealed away in the dark for over 3,000 years. Inside, among the gold and priceless artifacts, archaeologists find a simple, unassuming jar. When they open it, they find a thick, golden liquid that is perfectly edible. That liquid is honey. While civilizations rise and fall, one substance in your pantry is practically immortal. Today, we are breaking down the forbidden chemistry that makes honey the only food on earth that never spoils. All this we are going to learn today on Everyday Simple Science with Ray. If you are new here, kindly subscribe to our channel. Like and share this video and help us reach new people who are interested in learning about the what, why, and how of the universe. The journey of honey doesn't actually begin with bees. It begins with the flowers. To entice insects, flowers produce nectar, a sweet, watery liquid. This is where our hero, the female worker bee, comes in. She is a forager. Every single day, she visits up to 1,500 flowers. To make just 1 pound of honey, a colony needs to visit around 2 million flowers, flying a cumulative distance equal to orbiting the Earth 3 times. But why did bees start doing this in the first place? To understand the science of honey, we have to look back at their evolutionary history. Bees actually evolved from predatory wasps. Millions of years ago, before bees existed, wasps didn't really care about parenting. They would find insect larvae, drill down, lay an egg on them, and leave. When the baby hatched, it simply ate the host. Eventually, a group of wasps developed a stinger to paralyze their prey, becoming helicopter parents who stuffed insects into holes for their young. Over time, as flowering plants appeared, some wasps developed a taste for pollen, which is packed with proteins and lipids. These wasps eventually went vegetarian, becoming the first bees. This shift to vegetarianism created a new challenge: how to store food that wouldn't rot. Living underground meant fighting moisture and fungus. To combat this, bees started lining their nests with saliva and other secretions. They essentially learned to put their babies and food in plastic bags to keep them dry. As they moved from holes in the ground to holes in trees, they had to become even more efficient with their space. This led to the creation of the most obsessed over geometry in the animal kingdom, the hexagon. Honeybees use wax, which they secrete from their own bodies, to build their nests. To make a single pound of wax, bees need the nectar from about 2 million flowers, which they process into roughly 7 pounds of honey first. Because wax is so expensive to produce, they must use the least amount possible to create the strongest structure. While circles leave gaps and triangles or squares waste material, the hexagon tessellates perfectly. Each cell shares walls on all sides with virtually no wasted space. Even the bottoms of these cells are cups made of 3 diamond shapes, so when you flip them over, they form the base for the cell on the opposite side. It is mathematical perfection built in total darkness. When a forager lands on a bloom, she uses her long, tube-like tongue called a proboscis to suck up the nectar. She doesn't digest it like normal food. Instead, she stores it in a specialized internal pouch called a honey stomach, or crop. This is where the true chemistry begins. Inside this stomach, the nectar mixes with a special enzyme called invertase. This enzyme immediately starts breaking down the complex sugars of the plant nectar into simpler, more digestible sugars, glucose and fructose. Once her honey stomach is completely full, the forager flies back to the hive. At this point, the load of nectar can weigh almost as much as the bee itself. But she doesn't just spit the nectar into a cell. She passes it on to a younger processor bee, mouth to mouth. This process of passing nectar from bee to bee can happen several times, and with each transfer, more enzymes are added. This isn't just about making it sweeter. It is an act of biological warfare. These enzymes create trace amounts of gluconic acid and hydrogen peroxide, turning the mixture into an acidic environment that is highly hostile to bacteria. Honey is essentially a sterile, chemical weapon used to preserve food against fungal and bacterial invaders. Even with the chemistry right, the liquid is still far too watery. If the bees left it as is, the high moisture content would cause it to ferment and spoil. To fix this, the processor bees spread the watery syrup across the hexagonal wax cells. Then, thousands of bees perform a coordinated miracle. They stand over the cells and beat their wings at incredible speeds, up to 150 times a second, creating a continuous draft of warm air throughout the hive. This constant fanning evaporates the water, dropping the moisture level from around 80% to less than 18%. Finally, the liquid becomes thick, sticky, and immortal. To protect their masterpiece, the bees seal the cell with a fresh, airtight layer of beeswax, locking it away for the winter. For most of human history, getting this honey was a destructive process. We would find a wild nest, subdue the colony with smoke, and raid everything, often destroying the hive in the process. This changed in 1851, when Lorenzo Langstroth noticed something he called the bee space. He realized that bees always leave a tiny 3/8 of an inch gap between their combs and any surrounding surface. If the gap is smaller, they seal it with propolis. If it's larger, they fill it with comb. By designing a hive with removable wooden frames spaced exactly 3/8 of an inch apart, Langstroth allowed beekeepers to lift out honey without killing the bees or destroying their home. This remains the global standard for beekeeping today. On a modern apiary, this process is scaled up significantly. When it's time to harvest, beekeepers use smoke to mask the bees' alarm pheromones, making it safer to open the hive. Instead of brushing bees off by hand, high-powered blowers are often used to sweep them into the lower brood chambers. The full boxes, or supers, are then taken to a honey house. The frames pass through an uncapper, where vibrating heated blades shave away the wax seals. The frames then enter a centrifugal extractor, spinning at 200 revolutions per minute. The centrifugal force flings the honey out of the comb and against the walls, where it drains into a collection sump. However, this is where the miracle food can sometimes lose its magic. Much of the honey you find in grocery stores, especially those in plastic bay-shaped bottles, has been heavily processed. To make honey move quickly through industrial pipelines, factories often heat it to 180 degrees Fahrenheit. While this prevents crystallization and makes the honey look clear and amber, it also destroys the delicate enzymes and probiotic benefits that make honey a health food. Furthermore, testing has shown that some commercial honey is contaminated with sugar water or high fructose corn syrup, and glyphosate, the active ingredient in Roundup, which can be picked up by bees foraging near industrial farms. True raw honey is different. It is often cloudy or crystallized at room temperature because it hasn't been overheated. In its raw state, honey contains hundreds of complex chemicals and polyphenols that actually improve insulin sensitivity and support gut health. Unlike processed sugar, which can cause inflammation and gut dysbiosis, honey mitigates the overgrowth of bad bacteria. The world of honey is also far more diverse than just the golden liquid we know. In the tropical jungles of Central and South America, there are species of stingless bees, like the marola bees. These bees don't build vertical hexagonal combs. Instead, they store their honey in little rounded wax pods. Their honey is much more watery, tangy, and acidic than standard honey. It is highly prized in local cultures for its medicinal properties and is used to treat everything from inflammation to cataracts. Whether it is the stingless bees of Costa Rica or the honeybees in your backyard, these insects are essential to our survival, pollinating 75% of the crops that feed the world. A single worker bee will produce just 1/12 of a teaspoon of honey in her entire lifetime. When you see that jar in your kitchen, you are looking at the life's work of thousands of bees, millions of flower visits, and a chemical process that has remained unchanged for millions of years. It is a true masterpiece of nature, chemistry, and teamwork. If you want to support these incredible engineers, the best thing you can do is plant a variety of colorful flowers in your garden to give them a safe, pesticide-free place to forage. By understanding the science behind the honey, we can better appreciate the tiny buzz that keeps our world blooming. Kindly subscribe to Everyday Simple Science with Ray. Like and share the video, and turn on your notifications. Also, I would love for you to click to watch the video currently showing on your screens.